So as we know, today we will have the quiz, and all the quiz questions related to the chapter 1 as I teach in the previous week. And I have the group, the chapter 1 to chapter 3, and then all of the grade is a part of the final grade, include the 30%. So after the today quiz, you will know how to prepare for the quiz and how powerful after I highlight some quiz problems on class, and then you will know how to deal with the problem during your quiz. Okay. So before the quiz, we still need to teach the material related to the chapter 2. And the chapter 2 material teach today will be your quiz in the next class. Okay, so you should take care of some importance I highlight on class. As the title showing here, the chapter 2 is corresponding to the topic of the fluid properties. And then the second slide always shows the learning outcomes in this chapter. Okay. Sometimes before we solving the engineer problems, we should define what are your system state and the properties. So it means before solving problems, you should describe the system first. And then you should define what's your state involved in your systems. And such as a kind of the state, for example, maybe you should tell the user no, the system is under steady state process or isothermal process. So before you solving problems, you should define the system, and then you should tell the users what's the state you have and what's the process involved in your systems. And then the most important parameters for solving problem is the property. So if after you define the system and the state, if you don't know how many properties involved in your systems, you cannot understand what's the solution for your problems. So that's why the next is finding the fluid properties. Okay? So in the following slide, I will teach you how many properties we'll teach today. And as you can see, totally we have the 8. We have the 8 properties we'll teach today. And one of the important properties, we call that the density topic. The density topic. So the most important fluid properties, one is the density. Okay? So when we are solving the problem, I will tell you some important ideas, include the constant density assumptions. And then I will teach you how changes in the density, especially for the water material, and corresponding to the pressure changes or the temperature changes. Okay? So after I teach some important properties, at least the 8 in these chapters, and then I will tell you the topic about the stress. So the first, I need to define the stress and pressure and the shear stress. And then I can explain how to relate the stress and the force. So the most important here, you will know totally of the 7 fluid force in these chapters. So right now we have the 2 key numbers. the first number is total, we have the 8 properties. And the second is we have the 7 fluid force will be teach today. Okay? And then only one important equations also in this chapter is the viscosity equation. So we have the viscosity equations, and the viscosity equation is defined by the velocity gradients and the dynamic viscosity. But we would like to apply the viscosity equations. We should know how can we apply no slip conditions, because if you don't have the no slip condition, you cannot compute the velocity gradient, and then you cannot calculate and apply the viscosity equation. So before we teach the viscosity equation, and then I will tell you what is the meanings of the no slip condition. Okay? And the final 2 topics in this chapter are the surface tensions and the vapor pressures. Okay? So the slide, we are trying to describe the system first and tell you what it is the state in this case and what's the property we need. Okay? So first, how can we describe the system just based on the figure showing here? So usually the engineer will select the tank in here, and we have the regulators here as to be the system for this problems. So this is the exercise of the water diving, and for me, I will select the tank here and the regulator here as to be the systems. And then there is not part of the systems we will call surroundings. The regions is not part of the systems. I will call that the surroundings, such as the bubble air in here, and maybe the water and the diver self. Okay, so it is not part of the system. I will call that the surroundings. So if you define the systems and the surroundings, and then you will have the boundary. So the boundary is simply separate the systems and the surroundings. Okay? So another case is shown on the buttons. This is the Flume experiment. It is a very famous experiment, and in the next semester you will have the practice experiment related to the Flume. Okay, in our fluid experiment laboratories class. And then this is the Flume systems. We know that what's the systems. I will pick up the water inside the Flume as to be the systems. And then I can define the surrounding. What is the surroundings? The surroundings should be the airs in here, and the channel boundary here. The solid channels tables is our surroundings. And then we can further define the boundary we have. So the boundary always separates the system and the surroundings. And the surroundings is not part of the system. I can call that the surroundings. So it's the system is most important. You should define the system first, and then you can figure out where is the surroundings. Okay? And then sometimes we build up the Flume experiments. We are trying to understand behavior of the motions of the sediment particle inside the rivers. Okay? So it's a very famous experiment we will practice in next semesters in the laboratory class. Okay? So after I define the systems, this is another case. How can we describe the state? Okay, so we have, as you can see the slide show the bottle, the two bottles, and we will call that, we define what the system. I define the airs inside the cylinders is our systems. The air inside the system is our system. Cylinder is our systems. And then I try to interpret the state. As you can see the sentence showing here, the state is the conditions of a system specified by giving values of properties. So what are the meanings? Because I have the state 1 and I have the state 2, and what's the given value of the property is how many properties will involve in these systems. As I mentioned, our target in system is the air. So the property, I may pick up the temperature and the pressure and the volume and so on. So this is our properties involve the systems. And then why the reason I separate the state 1 and state 2, that indicate I assume these systems under compressed process. This system is under compressed systems. So I wondering to see after I do the compressions, so how the property changes before and after. So I define the state 1 and the state 2 and see what happened for the property changes. And we should define start from state 1 and the state 2. What's the process we have? So we already know the process. First is we do the compress, right? We do the compress. But we should define during the compress process, what's the state I should describe first. So maybe I can tell you under compressed process, we can call that the state is the steady state. So you see here, the steady state is the properties of the systems are constant with the time. The properties of a system are constant with the time. That indicates no properties can be changes during the compressed process. And then I can call that the steady state. So no physical property changes with the time. Even though I apply the compress, and then my status start from the state 1 to state 2, but nothing physical property changes during the compress process. Okay? And then I can also tell you maybe under the compress process, we have the isothermal process, or we have the adiabatic process. So the difference is the isothermal is the temperature of the systems is always the constant. Also, I can tell you the adiabatic process, that means there is no heat transfer between the system and the surroundings. Okay? So sometimes we describe the system, and then we should define how the state we have. And for this example, we actually know the process is compressed. And I know I have the before compress and after compress, I have the state 1 and the state 2. And I should define what the state, maybe the steady state or isothermal process, also the adiabatic process, and then I can deal with the how changes with the physical properties we have. So I try to use the 2 slides and explain the reason why we should describe the system and the state before we solving the problems. Okay, so and what's the property we have in fluid mechanisms? So totally we can separate the property into two parts, the kinematic part and the material, the nature material part. So as I sentence showing here, the kinematic property characterize the motions of the systems. So it's a very simple idea that indicates all of the kinematic property related to the position, velocity, and the acceleration. So what the material property, which is characterize the nature material in the systems. So I just highlight some examples. So for example, is the viscosity, density, and the specific weight. That's we call that the material properties. So if in the following class, if we call that is the kinematic properties, that indicate all the parameters we are discussing with the position, velocity, or acceleration. And the others, we call that the material properties. Okay? So this is a very good slide. I just separate the totally we have the 8 fluid properties in these chapters. And I can divide all the fluid property into 3 topics. Okay, so the first topic is the correlated to the weight mass. And you can see this is the first one is the density, and the second one is the specific weight, and the third one is the specific gravity. Okay, and then that's why I say that is the weight mass topic properties, because all the properties showing here, the 1, 2, 3 are related to the mass. So the first one is the density, and the second one is specific weight. And usually I use the gamma in the textbook. And in last class, we know that the specific weight is defined by the density multiplied the gravity. So what is a specific gravity, which is the ratios of the specific density to the reference density. So usually we define the specific gravities. The reference density is the fluid. It's the fluid waters at the 4 degree. It's the fluid waters at the 4 degree. Okay, this is our reference densities. So in the following slide, I will teach more details about that. And then the second topic we call that is the viscosity. Okay, and then you can see the viscosity. We have the 2 types of viscosity. The one is the dynamic, and the another is the kinematic. So until now, we have the 5 fluid properties shown here, including the 2 topics related. First one is the weight mass, and the second one is the viscosity. Okay, and you can see how the difference between the dynamic and the kinematic viscosity. The most important thing is the density showing here. Okay, the mu in here is the dynamic viscosity, and it can be defined by some relationship between the shear stress and the velocity gradient. I will teach more detail in the following class. And then you can see only one difference is we take the mu and divided by the density will have the kinematic viscosity. And then we call that the nu. Okay? So, and why we divided the density with the dynamic viscosity? Because sometimes we have different definitions for our property. Okay? And then the final three properties, we have the bulk modulus and the surface tensions, and the vapor pressures. This is the final topic. Okay, this is related to our final topic. And as I mentioned before, the bulk modulus usually can help us to describe the compressibility of the material. Okay, so today we have the exercise. We know what's the bulk modulus, and we should calculate the bulk modulus to understand how compressibility of the material. And then the final two is the surface tension and the vapor pressures. I will teach you in the next class. Okay, so totally you can take account how many properties we have these chapters. Totally we have the 8. And the 3 related to the topic of the weight mass. We call it density, specific weight, and the specific gravity. And the second topic is the viscosity. We have the dynamic viscosity and the kinematic viscosity. So include the 2 properties in this topic. And the final topic, we have the 3 properties. We call that the bulk modulus, surface tension, and the vapor pressure. So totally we only have the 8 important fluid properties will involve in our chapters, this chapter 2. So you should keep in mind, totally we have the 8. And this is a very good exercise, tell you how to find out some physical properties just based on the table. Okay, so in our quiz or the exercise in the class, you don't need to remember some important physical property numbers because the physical property number will change under different temperature or under different pressure. So it's very difficult to remember all the values under different situations. So in a class, the exercise, or in our quiz, you don't need to remember the certain values, but I will provide the values, or I will provide the table, or I will provide the figures. So this is an example. If I provide the figure for you, you should answer the dynamic viscosity based on the questions. So, as I say in here, in imperial unit, okay, you know that the imperial units. So you can see the units dimension showing here is imperial, okay? And then the question is, what's the dynamic viscosity? So even though we don't know certain definition of the viscosity here, but we know that this is the mu, and we know we're trying to figure out the dynamic viscosity of what's the material is the gasoline, and what the conditions. The condition is under 150 degree F. So you double check the table. The table, the y-axis is the viscosity. So the y-axis in here is the mu, and the x-axis in here is the temperature. So we know that the vigor is the viscosity as function of the temperatures. And you should pick up your system target. The target involved in your system is the gasoline. So first you should pick up the gasoline in here. And then you know that the curve showing here is related to the gasoline. Okay? So the question is very simple. We already know the conditions. So I state the condition showing here, we should state the temperature, how large it is. So the temperature is the 150 degree. So you can find out the number in here, and I can draw the line for the 150 50 degree here, and I know that how the viscosity, so I can draw a line, and I can find the answer showing here. Okay, so this is a very simple idea. In our class, you don't need to remember the certain numbers of some important properties, because the property will change under different conditions. But then you should know how can we double check the values and find the value based on the figures. So finally, I may pick out the number, and I can answer the questions. But this is not the slide I would like to share for you. This is some important ideas also involved in the figures. As some words I show in here, you should consider how different viscosity between the gas and the liquid, right? And how the difference response for the effect of the temperature. Okay, so if you take a look, in this figure, the top, all the material on the top is the liquid, right? And you can double check. And on the bottoms, the material is the air. Okay? So we should know the viscosity of the liquid material are always higher than air, right? Because the curved line on the bottoms for the material air, but the top is for the liquid. So I know that the idea, this is the certain conclusions. The viscosity of the liquid is always higher than the gas. Okay, so no problem. We know that it's true. And the second, how responds the different material, how responds to the changes of the temperatures. So if you take a look, for all of the liquid material, the change response to the effect of the temperature are always show a decreasing curve. That indicates for liquid material, the viscosity will decrease when the temperature increase, right? Because the curve is show a decreasing trend. But if you take a look for the air, the curve shows a little bit positive slope. That indicates the viscosity of the air or the gas should be increase when the temperature increase, but not obviously, but a little bit positive slope. Okay, so this is a significant difference. This is a gas, and the top is a liquid, and all the fluid we are involved, the liquid and the gas. So I remember I have teach you the idea showing here on the previous class, but we just simply based on the figure, we can figure out all the property difference for different materials, such as the liquid and the gas. They are show a different trend, even though we always call that the viscosity, but for the different material will have a different behavior. Okay, so this is very important. So that's why I tell you don't remember everything. For our quiz or for our problem, usually I will put the certain values on the problems, or even though I don't provide, but you should based on the figure or the table to check the values. Okay, so this is the idea what I would like to share for you. Okay, so this is a very good exercise. We are trying to finding the fluid properties. So before as I mentioned before, you solving the problem, we should define the systems first, and then what are the state we have, and what's the property we need. Okay, so always we are looking for system, state, and property. Okay, so following these ideas, so what's our systems? So first, I know that the system. The first, we should know that the fluid in the system. Okay, so the system, the fluid, we know that is the air, right? Because the question is tell us what is the specific weight of the air. So we know that the air in here. And what are the state, the conditions? So we know that the condition is at the 20 degree. Okay, we have a 20 degree. So we know that we have the 20 degree temperatures. Okay, and what's the pressure we have? So we can see the question tells us this is 3 atmosphere pressures. But the pressure we call it here is the gauge pressure. So right now you didn't know what is the gauge pressure. So I can tell you the gauge pressure is the pressure, okay, it's the pressure relatively to the 1 atmosphere. So that indicates usually in our environment is the 1 atm, right? But the gauge pressure indicates the pressure, but relatively to the 1 atmosphere pressure. Okay, so we already know the pressure is gauge pressure is 3 atm. So we should plus additional 1 atm, and we call that is the absolute pressure. Okay, because the gauge pressure is relatively to the 1 atmosphere pressure. So if we would like to know the absolute pressure, we should plus additional 1 atm for our pressure. Okay, so we go back to see the key knowledge, the property we need to answer is the specific weight. Okay, so we should know the problem here. So the problem we should answer the property, but the property right now is the gamma. Gamma is our specific weight. So we don't know the gamma values, but we actually know the gamma should be equal to the log G, right? So we need to know the density first, and then we multiply the gravity. We can compute the gamma. So the certain unknown parameter right now is we don't know the density. And because the system right now, the target material is the air. So it's a property we can apply the ideal gas law to solving the problem, right? So after I describe the system and I know the state is under the 20 degree temperature and the 3 atms gauge pressures, and I know my purpose fluid property is the specific weight gamma, and then we know unknown parameter is the density. Okay, the density, but the topic is the air. So it's a property we can use the ideal gas law to solving the problem, because our target is the air. Okay, so if you remember how the relationship we have, so we have the equations. The equations very important is based on the ideal gas law, and we know that the P will equal to the log R T, right? So this is a very good equations can help us to find out what the density we have. Okay, so we can, based on the ideal gas law, we can rewrite the equation to be the law is our unknown parameters, and the law will equal to the P divided the specific gas constants and the temperature T. And the pressure P here, we know it is the absolute pressure. So we have the P, and we know that the P will equal to the 4 atm. And in here, I tell you the 1 atm is equal to a 101.3 kilopascal. Okay, so we know that what's the pressure? Absolute pressure here is 4 times 101.3 kilopascal is the 3 powers, and the unit is the pa. Okay, so we can use the calculator to calculate a certain value here, the 4 times. Okay, and we have the kilo, 1,000. So we know that the answer showing here should be the 405 and the 200, and the unit is the pa, but the certain dimension is the Newton divided the meter square, because the unit in here is the pressure. So the pressure is the force divided the area. So we know that the certain units is newtons and divided the meter square. And we should know what is the absolute temperature, right? So we already know the condition is 20 degrees. So the absolute temperature should be the 273 plus the 20. So we have the 293 absolute temperature. The unit dimensional is the Kelvin. Okay, so until now we only have the one unknown parameter is a specific gas constant. As I remember previous class, we tried to practice how to compute the specific gas constants. But in here, we don't need to remember everything. So I directly provide you the specific gas constant for the air. So you can just put the value into your equations. Okay, so all the number we have, so we can put the number on the equation is 405 200 newtons meter square, and we should divide it to the specific gas constant is 287, and here is the Joule. Joule is equal to the dimensional is a Newton multiplied the meter. Okay, and over the kilograms and multiply the absolute temperature dimensions. Okay, in my class, I always put the dimensional unit beside the number, so we can easy to figure out to do the dimensional consistency. Okay, and they can check the balance of the unit, and then we should divide the temperature, right? So the temperature in here is 293. And the unit is the Kelvin over 1. Okay, so I just put all the number into the equation and trying to do the unit consistent balance. So you can cancel out some units you already have. We can cancel out the absolute temperature unit. Okay, and we can cancel out the Newton, the fourth dimensional unit. And what's the final unit you have? You only have the meter square here, and the 1 meter in here, and the kilogram in here. So the unit is equal to the density dimensional. So you know the equation should be the correct. Okay, So you can use the calculator to compute the final answers for the density of the air. Okay, so it's a 405,200 divided to 87 and divided to 93. So the density in here is the 4.82 about, and a kilogram per meter cubic. Okay, so you can stop here. Why I tell you stop here? Because if you remember the density of the air at the room condition, if you remember the density of the air in room condition should be equal to the 1.2 around kilogram per meter cubic, right? If you check the table, I put on the slide in previous class. But right now, why we will have a very big density for the air? Because we do the compressions. How we do the compression? Because you can notice that here the gauge pressure is quite larger compared to the environment. So we do the compressions and the air can be compressed. So after we do the compressions, the volume changes and then the density will increase. Okay, so this number is larger than the density at the room conditions. But this is not the final answer we required by the questions. So in the next step, we should compute the gamma. So we know that the gamma is equal to the rho G. So we have the rho is the 4.82, and the unit is the kilogram per meter cubic, and we should multiply the one gravity is 9.81, and the unit is the meter second square. So the gamma, you should use the calculator to compute the final answer. Okay, so it's equal to around 47.2. And the unit is Newton per meter cubic. Okay, this is our final answers. Okay, so for this problem, you can follow me based on my suggestions. Sometimes we meet the problem and we are trying to solve the problems. We should describe the system first. And then I describe my systems, and the topic material is the air. So I pick out the air to be my systems. And what are the state? I state the condition is 20-degree temperatures, and my gauge pressures in the system is 3 atms. And then what the problem we are looking for the properties is the specific weight. And so I trying to figure out the gamma, how can I compute the gamma? But we don't know the density, right? And based on the system is the air, so maybe I can apply the ideal gas law. Okay, so based on the ideal gas law, we can find out the density we need. And then we finally compute the gamma. But the idea in here, important thing, is we have a very large density compared to the density at the room condition numbers. That's because in this exercise, we are under the compressed process. And the volume of the air under the compressed process is decreased. The volume decreased, so the density increased. Okay, and we know that the density of the gas can be compressed. The volume can be compressed for the gas material, especially for the exercise is the air. Okay, so in the following slide, I just put some important table to summarize some physical properties change with the different temperature and the pressure. So the topic showing here, you know that we are trying to discuss how responds to the temperature and the pressure for the different properties. So this table first shows the 3 important properties associated with the wet mass. Okay, so the first one is the density, the second one also the specific weight, and the final is the specific gravity. So we only focus on the first one, the density, because the follow property are similar to the density. Okay, so we only focus on the first property. So you see the table, there are show the units and the temperatures and the pressures. And there are some notes. That's a highlight. If you would like to double check, you can check from the tables we have in the textbook. So if you check the E3 platform, I already upload some important table and the figures on the website. So even though you didn't buy the textbook, but you still have the table or the figures on E3 systems. Okay, so you see for the temperature effect, when the temperature increase, the density should be decreased. Okay, this is for the gas. But for the liquid here, they are the same response. Okay, the temperature increase and the density decrease. So it's a common sense because we know that the temperature increase, the volume will become larger, and then the density will decrease. Okay, but the idea of the difference is for the pressure here. As you can see, these conditions is what I say in the previous slide. This is in here is for the gas, and then the previous slide, the exercise, the gas is the air. And we actually know when the pressure increase, and then the density also increase. It's for the gas. It's the same conditions compared to previous slide exercise. But most important thing in here, you can see in this portion, it is for the liquid. This is for the liquid. And for the liquid, it's usually idealized with the density independent of pressure. That indicates we may say the liquid material cannot be compressed. And then the density didn't change. Okay? So, in other words, in this topic here, that indicates the liquid is very difficult to compress. So resulting the density independent of the pressure for the liquid. Okay, so that's why I say the table is very good because it just summarizes some ideas on the tables. And you can figure out based on your knowledges. So because we already done the exercise in previous slide, so we actually know what the reasons the density will increase when the pressure increase for the gas. Okay, so this is a very good tables I'm trying to explain. And then in the following, you should take a look at the specific weight here. They are the same properties. So we are not going to detail in the following 2 parameters, the specific weight and the specific gravity. You can figure out by yourself. Okay, so the next slide just summarizes different properties with a different response of the temperature and the pressure. Okay, so maybe we have a 10 minutes break. And after the break, we will go back to class. And we are trying to step by step to looking for the different material with a different response for the temperature and the pressure. Okay.